Okay. Number 12. This is exponential equation. And this is the easiest exponential equation. How do you know it's easy? Because 1/3 and 9, both, we can express it like a power the one common base gets 3. 3, 3. This is 3 to the negative 1, reciprocal, negative exponent, negative 1, and 2, and 9. Therefore, you rewrite like that. 3 to the minus 1 raised to the 2x plus 5 equal 3 to the second power x plus 3. Okay. Now you apply the property of the exponent in which your multiplication, the level of the exponent, is 3 to the minus parenthesis 2x plus 5. It's important the parenthesis, right? Equal 3 2 times x plus 3. In that moment, we have two exponential functions, and the base is the same. Therefore, the exponent is the same. So basically, I remove mentally the exponent. I write something like that. Minus parenthesis 2x plus 5 is equal to 2 times x plus 3. And we have in that moment linear equation. Minus 2x minus 5. 2x plus 6. So I propose you, for example, you move, so this negative 5 stay here. I move negative 6 to the left, 2x stay, and plus 2x. We combine, negative 11. Negative 11 equals 4x. Finally, divided by 4 both sides. Negative 11 over 4 is the x. Any question? Question, guys? No? Everything okay? Come on, I want participation. Good or not good? Good, very well. Okay, super. Okay. Nice. Well, let's do number 13. It's similar. Very, very similar. So 13 is 1 over 5 raised to the x plus 2 is equal 125x raised to the x. And likewise, 1 over 5 is 5 to the negative 1 raised to the negative 1. No? And 125 is 5 cubic. 3 times 5. So 3 times no. 5 times 5 times 5 is 125. Replace 5 raised to the minus 1 x plus 2 is equal 5 to the cubic raised to the x power. One more time, you apply the properties of the exponent in which you multiplication. Entonces 5 multiplied by negative x plus 2 equal 5 raised to the 3 times x. If two exponential function, the base is the same, then the exponent is the same. Minus x plus 2 is equal to x. And so for x. Apply distributive property here. Minus x minus 2 equal 3x. Minus 2 is equal to 3x plus x. And move x, negative x to the right hand side. The right hand side is positive, no? Then minus 2 is equal to 4x. Combine that term. Divided by 4 finally. Is negative 2 over 4, or much better, and negative 1/2. You reduce the lowest term this way. End story. This is the easy. I promise in the test. Well, you see, we have one question that we can solve it in that way. So manipulate both sides and express it using the common base, and in this case was 5. But sometimes no, sometimes it's impossible. So next problem, 14, 15, and 16 is impossible to do it in that way. Impossible. So you need to apply, when it is impossible, what should I do? Well, I apply logarithm of both sides. What kind? Standard. Because finally we finish in the using the calculator. Any question in this problem? Any? Come on, come on, come on. Okay, good. Inaya is good. Victoria Ferrer, who is, okay, who are you? Victoria John, uh, Kyla. Okay, good, very good, very good, very good, very good. Okay, super. Let's move on to the 14. 14 now. 14 is 14. Now, 14, 1, 4. 14. 14 is 5 raised to the x plus 4 equal 4 to x. This is clear. It's impossible manipulate both sides in order to explain the computer. No, impossible. Now you apply logarithm. What time? It's time. LOG, que es exactly the logarithm that we have in our calculator. This LOG is common logarithm base 10, and we can press the key LOG in our calculator and you get it. Now in this moment you apply the property 7. The property 7 allows us this exponent go to the front as a expression, factor. Just x plus 4 multiplication log of 5 is just a number I can compute it with the calculator. X time, this is time, period, time. I don't know exactly. I understand when it's missing, the arithmetic symbol, I suppose it's time of 4. Don't forget the parenthesis always to enclose the argument of the logarithmic function. Now distribute the property because my goal is do something in order to solve for x. Distribute the property. This is just a number. It's just a number. The multiplication. This times this. This times this. That's x times log of 5 plus 4 log of 5 equal x log of 5. Okay, my goal is solve for x. I try to move, for example, okay, this state is a linear equation. So we have x log of 4 minus x log of 5. Now I can see that x is a common factor. I factor out x. We have actually 4 log of 5 equal x factorization log of 4 minus log of 5. Divide both sides by this guy. Log of 4 minus log of 5. Both sides. Log of 4 minus log of 5. Finally, x is equal. Okay, x is equal 4 times log of 5 division log of 4 minus log of 5. And leave it like that? No, because before you put in the calculator the number, you have to condense several logarithms of only one. So in my opinion, it's easier in that way. Okay. Easy to make. In the top part, I apply property number 7, pero backward. I put log of 5 to the 4 power. No? And by the way, 5 to the 4 power is 625. 5 times 5 times 5 times 5. If you want directly, I replace 625. In the bottom, no. In the bottom is logarithm of 4 over 5. Because we apply the property number 6 on a subtraction and division. And now we are ready to put in the calculator. Okay. Listen to me. Let me analyze something before calculating. The answer I expect is positive or is negative. What do you think? The answer, when you finish to put in the calculator, the answer that we expect is positive or is negative? Come on, I want to hear your opinion. Positive or negative? And how do you know when the answer, when the computation involves logarithmic function, how do you know it's positive or how do you know it's negative? What is the clue that give me information about that? Come on. You don't remember? Don't remember? Okay, when the number, so the base is 10. This is clear. And 10 is greater than 1. But 625 is greater than 1. It's obvious, right? So this logarithm is positive. So when you have different directions, C is greater than 1 and the base is less than 1 or opposite. But 4/5 is obvious it's less than 1. So 4/5 is in decimal, 4 over 5 is 0.8, no? And 0.8 is less than 1. So this logarithm is negative. This logarithm is positive. But okay, let's do it. This rectangle represents the display of the hour calculator. You put LOG, open parenthesis 625, division, LOG, or 4 division, something like that. And remember, the answer I want to round using 4 decimal place. Okay, you put in the calculator. Come on, everyone working with the calculator. LOG 625, division, LOG 4 over 5. Boom. Tell me, what is your answer? I did in my calculator. What is your answer? Around the near 1,000. Let me see. 1, 2, 3, 4. Yes. 2885. Let me see. 1, 2, 3, 4 decimal place. I need 4 round to the near 1,000. No, 2 decimal. You are right. You are right. You are right. It's minus 28.85. Not 4 decimal. 1,000. 2 decimal. Because the next digit is 0. So actually, when in the calculator, I saw something like that. 0 to 6, 976. I need 2 decimal, 1,000. You delete that. You go to the next digit. This is fine. And this is exactly we predict negative solution because the reason it's negative is because this logarithm is logarithm of the number less than 1. If it's greater than 1, positive. If it's less than 1, negative. And positive divided by negative, it's obvious that positive divided by negative, it's obvious. Any question? Come on. How do you feel? Is it clear? Is it confusing? Very, very confusing? Clear. Alicia Figueroa say clear. Okay, Alicia. And the rest, it's okay or no? I need to hear opinion. Question. Remember, I cannot help in the test. Okay? Clear, Hinaya. Super, Hinaya. Okay, guys. Clear, Joanna Cruz. Okay. Let's move on to the question 15. Okay, 15 now. 1, 5. 15 is similar, no? It's similar. 15 is 4 over 3 raised to the 1 minus x equal 5 raised to the x power. This is again classical example in which you can apply logarithm on both sides. Remember, guys, two standard, LOG or LN. Any logarithm you apply standard, the answer doesn't change. For example, in this case, I want to do using LN. Okay, LN. It's the same, but let's practice a little bit LN. To apply logarithm on both sides. Don't forget the parentheses. Remember, this is the name of the function, LOG of something. Something inside. Something. Okay, have no sense to talk about LOG of 5. What the hell is that? This 5 multiplication or what's the argument? Now you apply the property number 7. One more time. This exponent go to the front as a factor. Then 1 minus x parenthesis multiplication ln 4 over 3 is equal to x times ln of 5. And don't be scared because this and these are just a number. A number that we can compute with a calculator. So you try to do exactly like a linear equation. Your multiplication, this number times 1, this number times minus x, so you have ln 4 times 1 is the same minus x times ln 4 over 3 is equal to x ln of 5. Super. Now my goal is solve for x. I have to manipulate this linear equation in order to put the x in the same side. Maybe ln 4 stay here in the left. However, x ln 5 stay also in the right, plus x ln 4. Okay. Now factorization. Is there a common factor? Of course, yes, x is common factor. I factor out. Factor out. Inside the next parenthesis or bracket, whatever you want, is ln of 5 plus ln of 4. Divide both sides because my goal is solve for x by ln of 5 plus ln of 4. Yeah. So obvious, it is part is cancelled, that was intention, and x alone is ln of 4 divided by ln of 5 plus ln of 4. Okay, the top stays the same because we have only one logarithm. Before to put in the calculator, I recommend, not exactly mandatory, but I strongly recommend condensing the logarithm. Is property number 5, using the property number 5, que is plus, is multiplication, which says 20 over 3, no? Because 5 times 4 is 20 over 3. Multiplication with whole number times a fraction, you know, it's super easy. The supposition the whole number is 1 in the bottom, multiplication top, bottom, 20 over 3. Okay, and this is the thing que I put in the calculator. Again, this is the display of the our calculator. And you put ln 4 over 3 division ln 20 over 3. You know, not like that. Over 3. In the calculator, you put division 3. Okay. We expect positive solution or negative solution. What do you think? Positive or negative? Positive or negative? Come on, I want to hear opinion. Positive or negative? Negative. Hinaya is a negative. Okay, Hinaya. Alicia? What mean this heart? Alicia? You love that. Okay, Hinaya, look, listen to me. The fraction that we have is greater than 1 or less than 1? Victoria, Less than 1. No. Put it in the calculator. Hinaya, put 4/3 in the calculator and convert to the decimal, and 20/3. What is this noise? Now let me see. Oh, Hinaya, greater than 1. Therefore, Hinaya, what do you think? Positive solution or negative solution? Joanna, group, positive or negative? Natalie, positive or negative? Pascual, positive or negative? Ismael, positive. Alicia say positive. Okay. Okay, I don't know. I have no idea. Let me try to put it in negative. Negative, Mael. Why negative, Mael? No. Okay. I want to repeat. Okay, positive, Joanna. Okay, good. When the number inside the logarithm is greater than 1, the logarithm of box, and this box is greater than 1, this logarithm is positive. When the box is less than 1, this logarithm is negative. But in our specific case, 4/3 is greater than 1. It's obvious, right? And 20/3, of course, is greater than. So the answer is positive, I suppose. Okay. Let me try. ln parenthesis 4/3 division ln again 20/3. Boom, I got it. Again, they want you round to decimal place. What's the answer? 0.52. Okay, but they want Hinaya. They want only 2 decimal place. No thousand. No, 8,000. 3 decimal place. You're right. Entonces es 0. What do you say? 0.11. Let me copy the number I see in the display of the calculator. Okay, I like this way. You don't make a mistake. You copy the stupid number. And I want 3 decimal place. 1, 2, 3. Eso porque the next digit is greater than 5. Then you increase it. Entonces 0.15. Very fine. Any question? This was 15. I make a zoom to the people who will want to take a picture. No? But not take a picture. You have the video. Let me ask you something. You using the video? You watching the video? Not always, but you watching the video? Yes or no? It's useful. Okay, yes. Next question. You see in YouTube or in Blackboard? Yeah, Joanna? Both? Okay. Okay, nice. Blackboard. Okay. YouTube. You know, some people prefer YouTube, and other people prefer Blackboard. Explain me why you prefer Blackboard or you prefer YouTube. What is the advantage and disadvantage of the both platform? I don't know because I don't see. I see in YouTube only. In Blackboard only I posted. Advantage and disadvantage. It's the same or there are differences. Joanna, what is the another guy again? You don't want to share your opinion? Okay. Okay, guys. I usually already in Blackboard other class, but I have in YouTube. Okay, perfect. I understand. Because another teacher posted only in Blackboard, not in YouTube. But I have my YouTube channel for a lot of years before. Okay, super. Okay, let's move on to 16. 16 is a little bit weird. 16 is a little bit weird. 16 is typical equation. It's exponential equation, of course. But it's equation that you can solve it using the quadratic in front, no? Whichever is available first. Okay. The problem is, Joanna, okay, I posted the in YouTube this weekend, any weekend. Entonces, the Blackboard I posted immediately. When I finish, I posted. Entonces, it's early in Blackboard, no? This is the reason. Well, okay, in this equation, you are doing substitution u equal to the x, because I can see that this is typical quadratic in form. What is the most important characteristic of this kind of equation is that we have one expression, and we have another expression here that is a square. So the exponent is duplicated. So this is super easy, super smart, compared to the quadratic equation, because you take advantage and you define one auxiliary variable u. This is u, but this is u2, or u squared, sorry. Okay, now by factorization, yeah, it's possible by factorization. Because the combination is, let me see, 4 and 3, no? 4 and 3 together, or multiplication, 4 times 3 is 12, and addition or subtraction, 4 minus 3 is 1 here. Entonces plus, all right. Super. You separate two linear equations. The first one is imply -4, and the second is imply +3. Now you split the paper into parts. For u equal -4, and for u equal 3. Who is u? Well, u, remember, is 2 to the x by definition, our definition. So I replace, because my final goal is solve for x. So you need to find the original variable value to satisfy the equation. So 2 to the x equal -4, and 2 to the x equal 3. It's obvious that this is a stupid equation. Why? 2 reasons of the identification. I know very well that the exponential function never is negative. Look like that. So this and -4 is 1, 2, 3, 4. But this line, horizontal line, que is the right hand side, and the curve, que is the left hand side, never intersecting. No common point. It's no solution. This is one point of view. Okay. Another point of view is, suppose I don't remember anything. Okay. You apply logarithm both sides. And immediately you see surprise. Logarithm of a negative number is totally undefined. You put in the calculator. Let me try to put in the calculator. Let's see in my calculator what the matches. And not always calculator have the same matches. Logarithm of -4 is domain error. Domain error. In my calculator TI 30. Domain error. That means it's totally outside the domain. Okay? It's impossible. Logarithm of negative number, impossible. Logarithm of 0 is impossible. This is completely out of the domain. Okay, so you discard -4. 3 is yes. Very easy. You apply logarithm. What kind? I like in this moment comma. Why not? In this case, you apply property 7, que allow us this exponent go to the front. X times log2 is equal to log3. Final divided by log2 both sides. I have then x is equal log of 3 divided by log of 2. Okay. And at that moment, I put in my calculator. LOG of 3 division LOG of 2. Okay, before do that, what do you think? Is positive solution or negative solution? Positive or negative? Come on, come on, come on. Positive or negative? Positive or negative? Answer me. Hey, what's going on? Positive solution or negative solution? Ismael, positive or negative? Alicia, positive or negative? Inaya, positive or negative? Victoria, positive or negative? No answer. Are you frozen? Positive. Why, Hinaya? What is the reason, Hinaya? Ismael, what is the reason? What is the reason that the answer of this problem is positive number? Of course, it's irrational. It's because it's greater than 1. Both. Very well, Ismael. Okay, let's do it. I need help. Come on, put in the calculator and let's try. LOG of 3 division LOG of 2. I got it. Help me. What is the answer you get? I'm getting round to the near 1,000. 1,000, 3 decimal place. Come on. Come on. I wait for you. Uh-huh. 1.585. Exactly. The answer is 1.58. Let me copy completely. 4.962. At least in my calculator, this is the digit. Not necessarily in every calculator it's exactly the same, depending the electronic approximation. But we need 3 decimal place. The digit is 9, que greater than 1, greater than 5, sorry, greater than or equal. 1.585. It's the final answer. Que positive number exactly we expect. How do you feel in the exponential equation? Remember, we have 2 kinds of exponential equation. One exponential equation que es easy, que we can do using the idea of the separate no, express both sides using the common base, but sometimes it's impossible and you need to apply a logarithmic both sides. O acá en estándar, either way, natural or common, entonces we finish the problem with the calculator. Okay, we have now 3 more examples, 17, 18, and 17, 18, and 19, que es the logarithmic equation. Logarithmic equation. Okay. Okay. Okay, logarithmic equation. Suppose 17. 17 is weird. 17 is logarithm base 4 of x minus 7 plus logarithm base 4 x minus. It's weird because they are repetition. It's the same equal one. And remember, what is the strategy for solving any logarithmic equation? Well, number 1 step is condensing. Condensing, we have 2, 3, 4, 5. Logarithm, you condense it in only one logarithm. We have 2 logarithms, you condense it like only one, no? And you apply the property number 5 because it's plus. So multiplication this and this, by the way, is the same to the brother. X minus 7 squared. Another student say, well, professor, if you combine like term, because it's the same as twice. Okay, let's do it. 2 times LOG of 4x minus 7, no? Because this guy is exactly the same of this, no? To say this plus something, something plus itself is twice, no? And you apply, for example, the property number 7, and these 2 you put in that like exponent, and we come back to this. It's another point of view.
It doesn't matter. It's the same. Now, in this moment, immediately after, when you condensing several logarithms to only one single, you convert to exponential statement. Now, this is the most important part, in my opinion. The base is 4. So this is small 4. I put a big 4. Big 4. The exponent is 1. 1 here is invisible, no? It's invisible. It's equal to x minus 7 squared. X minus 7 squared. Entonces, in that moment, guys, we have quadratic equation. Quadratic equation. Always. Not always, but frequently. Quadratic equation, we ending in quadratic equation. So I take advantage for solving this quadratic equation. Let me copy it like that. You apply, I propose you apply square root both sides because I take advantage. Can somebody do the factorization? Entonces, square and square root cancel out, x minus 7. Good. And at the right hand side, we have plus and minus 2, no? Because the square root 4 is 2, and don't forget plus and minus. So finally, we have x is equal 7 positive plus or minus 2. We have two solutions. Is 7 plus 2 gets 9. And 7 minus 2 gets 5. And that's it? No. Why no? Because logarithm equation is mandatory checking. Remember, logarithm equation is very, 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 very picky. Logarithm function is very, very picky and do not accept negative numbers. So you need to check this potential solution one by one into the original equation. Let's move on. Suppose x equal 9 and x equal 5. Split the paper. Plug it in, plug it in, plug it in the original. Logarithm base 4 of 9 minus 7 plus logarithm base 4, 9 minus 7 should be, I cleaned up because I'm not sure that this statement is true for equal 1. Likewise, logarithm base 4 of 5 minus 7 plus logarithm base 4 of 5 minus 7 should be 1. Exactly the same. I claim that. I'm not sure that this is 10 meters. Let me start from 5. It's obvious that this is completely stupid equation. Yes or no? Because 5 minus 7 is minus 2. And minus 2 inside, undefined. So 5 doesn't work. 5 is the solution for the quadratic equation. So remember, we are doing algebraic transformation. And when you are doing the algebraic transformation, sometimes happens that one solution is completely out of the domain. Si it's out of the domain, it's no solution. So we see that at the beginning in this course when you have radical equation. It's the same. Radical is picky, logarithm is super picky. Okay, entonces 9 minus 7 is 2. Oh, at least this is positive. No problema. Plus logarithm base 4 of 2 should be 1. Okay, how we can prove that this statement is true or false? Well, exactly the same we are doing always. Condensing this logarithm in only one. Entonces, apply the property phi one more time. The logarithm of base 4 of 2 times 2 is 4. Ooh, and remember, when the number is the same inside the argument and the base, apply the property number 2 is equal 1. This is super true. 8, 9 is perfect, 5 is no good. Okay, so the solution set for this equation is just 9. Solution set 9. Any question? Important, guy. I want to see when you solving the logarithm equation in the test. You checking the potential solution, always mandatory. And the potential, no. Why no? Because remember, the domain of the exponential function is a real number. Exponential is no picky, exponential is super nice function. So accept any solution. Well, si you are solving well, the answer is correct. But suppose here we are solving well, however, 5 doesn't work. Only 9 work. So it's mandatory checking in this case. Any question? and the 17. Question. It's clear or not clear? Come on. Exclamation. Yes, clear. Okay, super. Let's move on to the 18 now. 18 is, okay, 18. 18. 18 is log of x plus 3. 1 minus log of x. Okay, help me please. I'm in big trouble. Help me please. What should I do? What should I do? It's the classical procedure in the logarithm equation. What should I do? What should I do? What should I do? Say again? I don't hear very well. Loudly or use on the chat, please. Hinaya, no? What do you say, Hinaya? Help me, come on. You know or you don't know? You are totally lost? Natalie, Joanna, Kyla, Pascual, Hinaya, you say something, no? Or no? Condensing. Okay, Hinaya say condensing. This is correct, Hinaya. However, what is the problem? The problem is that the logarithm is in different side. So what should I do? Step number 0. Move either one to the same side. No, log x plus 3 plus log of x equal 1. So Hinaya say in this moment you're condensing. Okay, using the property number 5. One more time. Log, entonces multiplication, no? Es x time, let me put it in this order, x plus 3. And this parenthesis, but don't forget the parenthesis can close everything, right? Equal. Okay. It's correct? Condensing. Now this is the most important moment in which you convert to exponential. My question is, what's the base of this logarithm? It's missing here. I don't see any number, professor. What is the base? What is the base? What is the base? What is it? What do you say? 10. Joanna say 10, professor, because when it's missing, I know it's 10. Perfect. It's 10. And the base is 10. What is the exponent here? Conversion, logarithmic statement to exponential statement. Classical problem in college algebra. The exponent is, what is the exponent? 3. No. Where is the 3? This 3. Are you crazy? No. Okay. 1. This 1 is exponent. So the answer, I repeat 40 times, 41 times again. The answer for the logarithm represents the exponent always.
Here's what I found online.
Okay. The answer for the logarithm statement represents the exponent in the exponential statement. ¿Qué es 1 here? The 1, you know, is invisible, not necessarily to write. It's equal to the rest. The rest is x times x plus 3. Well, in this moment, we have quadratic equation. 10 is equal x squared. I got it, right? Okay. Plus 3x. Entonces, the quadratic equation que I have in my hand in this moment is x squared plus 3x minus 10, because I need to write or express it in standard form. So I move everything to the one side because the right-hand side must be 0 to start. I don't know if it's possible by factorization. I suppose yes, right? This is regular trinomial factorization. es 5 and 2, no? Because 5 times 2 is 10, and somehow 5 minus 2 is 3. This is positive, this is minus. So we have the solution, no? Guys, don't be scared. So you don't remember very well factorization. I suppose that the student took with me the intermediate algebra very well remember factorization, no? Because I explain in detail and you are doing well. The other student, well, if you don't remember, you can apply the quadratic formula always. Yeah, I know it's too long, but always work. Okay? But no. I do in the easy way. The answer is negative 5, sorry. Negative 5 and x minus 2 equals to 0. The answer is positive 2. Okay. Now, I need to check it. But it's obvious. It's obvious that negative 5 doesn't work. But why? Because negative 5, when you put in here negative 5, or here negative 5, plus 2 is negative 2, no? Negative 5 is crazy, it's completely out of the domain. So I try to prove that 2 works, because maybe it doesn't work. There are no guarantee, because some equations have no solution. So I try to prove. Plugging into the original. What is the original? The original is, let me make a zoom. Ah, yes, I saw. Logarithm of 2 plus 3 should be equal 1 minus logarithm of 2. Yeah, I claim this statement. I'm not sure if it's true or false. Should be true or should be false. I have no idea. Okay, well, at least 2 plus 3 is 5, no? At least logarithm of 5 is equal 1 minus logarithm of 2. Okay, so we are doing exactly the same with the solution. You move logarithm of 2 to the left hand side like a plus, no? And it is 2, sorry. This is 2. So this guy, I bring here. Now condensing is logarithm of 5 times 2 is 10. And this statement is true or false? Logarithm of, ¿cómo logarithm of 10? Es 1, yes or no? It's true. Remember, property number 2 says, when the base of the logarithm is coincident with the number inside the argument, always is 1. And in our specific case, it's logarithm of 10. And what is the base? Oh, I know the default is 10. Because I need to know that when there's no specification, when it's missing, it's because it's 10. So they are perfect coincident. That's the reason they want. Also, if you want, put in the calculator, please. Put in the calculator. Always we can check in using the calculator. You put in the calculator, log of 10. Press enter, the answer is 1. Okay? So now to work, this is my solution. And the solution set for this equation is solution set just 2. Any question? Super clear or super confusing? Super confusing or super clear? Or very weird or clear? Inaya is clear. Alicia clear. Okay. Ismael, confusing, clear. Okay, let's do one more example. Is the 19. End the story. No, end the story, no. Okay, I want to finish for today. Remember, immediately, you stay here with me. I want to send the final test. Remember, the final test is created for help the students. It's very, very smart. So you, for example, you fail one test, or you are missing one test. We are talking about on paper and online, because some people are doing a mess online. So I consider the grade of the final like one extra test. y ahí incluye en the gradebook. Entonces, I replace the worst test. O sea, suppose que you are missing one test online. You have 0. Entonces, now you get, for example, 80. In the final, I replace 80. Entonces, I average every test. Que, by the way, you know, que we have 8 tests. Actually, we have had a 9 tests. Pero I replace. Entonces disappear the 9. It's no 9, it's 8 again, it stays the same number, and you adding now 80, no 0. So you improve a little bit your grade. I don't know if you pass or no. This is when I compare everything, so I realize you pass. Okay, let's move on to the last. So stay, because I want to say no now. When I finish 19 problem, okay, and I am sure that you understand very well that you are ready to take the test 4. Okay, you have one on. You start today, you take a look, you solve one question, after you solve another question, after you try to find one tutor to explain another question. I don't know. It's up to you. Try to ask for help, maybe, no? I understand this. Okay. 19 now. 19, 19. Okay, 19 is log of 2x plus 1 equal 1 plus log x minus 2. Okay, this is similar. This is similar to the 18, except, so similar in the sense que es a common logarithm, so the base is 10. And we try to move the two logarithms, my equation in the same side. For example, this guy stay here, and this no. I move subtraction like that, equal 1, no? Now we're condensing, in this case using the property 6, because it's subtraction. When you're condensing, is division. 2x plus 1 in the top, x minus 2 in the bottom, equal 1. Now you convert to exponential statement. The base is 10 again, the exponent is 1 again, so it's 10. Don't repeat it, 10. It's equal to x plus 1 over x minus 2. In this case, we have linear equation, no quadratic equation. And you apply like a proportion, no? You multiplication 10 times this and 1 times that. Entonces, 10 times x minus 2 is equal to x plus 1. 10x minus 20 equal to x plus 1. Okay, solve for x, linear equation, easy. Is 10x minus 2x is equal 20 plus 1, no? Is ax, x equal 21 over 8. Okay, and this is my potential solution. I need to check it. In this case, we have only one solution because it's when you manipulate the logarithm equation, you get linear, no quadratic. Quadratic give me two solutions. Maybe one is good, another not good, or both are not good. But in this case, linear give me only one solution. So I need to check in the original equation. Okay, in the original equation. In the original, yeah. Is log of 2 times 21 over 8. So you replace x for 21 over 8. Plus 1. Should be equal, clean that. 1 plus logarithm of 21 over 8 minus 2, no? Minus 2. This is the thing I need to solve. Okay. What should I do? Well, you multiplication here. But multiplication is a smart way. You divide by 2 here at 1, divided by 2 at 4, no? So actually, we have logarithm of 21 over 4 plus 1 should be equal 1 plus logarithm of okay, let's combine. Okay, we have fraction here. You can use a calculator, but okay, let's do it by hand. It's easy. 21 over 8 minus 2. This is equivalent to say 21 over 8 minus 16 over 8. Yes or no? So because my least common denominator is 8, no? Then see, my least common denominator is 8. 8 times 2 is 16. So 21, now 21 minus 16 is 5. So 5 over 8. Actually, this is 5 over 8. Okay, and similar, 21 over 4 plus 1 is 21 over 4 plus 4 over 4, no? Because the least common denominator is 4, no? So if 1 is 4 times 1 is 4. This is 25 over 4. I need to prove que el logaritmo of 25 over 4 is equal to 1 plus logarithm of 5 over 8. I need to prove this. And that moment, if you want, we have possibility. So suppose that you don't see the way, okay, because it's complicated, maybe artificially. You put in the calculator. You put in the calculator and you get a weird number here. You put in the calculator this guy, and you get the weird number. And you put it here in the calculator, you get another weird number, but it's different weird, no? And you add in 1, and see you prove that this is equal to this, it's perfect. It's a one possibility. Okay, I understand very well. However, I propose one more elegant solution. One more elegant solution is similar. You move this guy to the left, subtraction, logarithm 5 over 8 should be 1. One more time, you apply property number 6 because it's subtraction. Entonces, basic es logaritmo of division 25 over 4, 5 over 8. Should be 1. 25 over 4 in the top, 5 over 8 in the bottom. Let me do division. 25 over 8, division 5 over 8 es recíproca, ¿no? And recíproca is flipped. Flipped is, sorry, this is 25 over 4, copy the top, exactly the same, time, flip it, 8 over 5. Okay, entonces, bueno, okay, multiplication, or not necessarily multiplication. You simplify, divided by 5, 1, divided by 5, 5, divided by 4 is 1, divided by 5 is 2. Wow, 5 times 2 is 10. This is 10, unbelievable, but it's true, it's 10. I know very well que el logaritmo of 10 is 1. This is 10, is super true. Is 1, super true. Okay, but I don't remember what was the solution that we found. One of the solutions that we found was, I don't remember. It's a weird solution, no? 21 something. Look at that, this 21 over 8. So the rest I did after that was try to prove it's true. This is the solution set is 21 over 8. Any question? Complicated? Well, the complication in this is the fraction part. But okay, we can use a calculator if you want. Not necessarily do it by hand. I do it by hand to illustrate the idea. Okay, for today, enough. Stop. I want to send the final test. No, all students need to take, no. Suppose that you are good grade, or you consider it's good for you when you average. You don't know the grade for the test number 4, but you're using your imagination. It's the only test that you don't know exactly. With the test number 4 online, when you submit, you know your grade. But the test number 4, you don't know, but you're using the imagination. You are doing well, Professor. I understand very well that part. Okay. I send the test, guy. Let me know if you receive or no. And if you receive, you can leave. And remember, Wednesday with me here to discuss in detail final.
I got it.
Yeah, exactly. Bye-bye. I got it. Okay, thank you. Thank you. Have a nice day for everyone.